Welcome everyone. This is the actual lesson recording for February 1st, 2021. So goal for the day is that we're going to be studying the third form of quadratic equation, the vertex form. As an example, here is my standard form of quadratic equation. Y is equal to 2x squared minus 3x plus 1. And the vertex form would look like y is equal to 2 times x minus 3 all squared plus 1. Okay, the numbers look very similar, but what's the difference? Well, the difference is with the standard form, the squaring is only on the x term. Okay, the squaring is only on the x, whereas in the vertex form, you have a parenthesis, and x minus 3 is being squared. Okay, so it's not just x, but there is subtracting 3 first and then being squared. Now let's specifically look at the first number that is being multiplied to x squared here and there in the standard form and the vertex form. What's going on here? 2 is being multiplied to x squared. In this case, 2 is being multiplied to x minus 3 all squared. So there is no isolated x squared term by itself. So in general, well, it's not just in general, always. The vertex form is written as y is equal to a, parenthesis, x minus h all squared plus k, where a, h, and k are all constants, and a is not equal to 0, because if a is equal to 0, it would not be a quadratic function. And a, h, and k, they're all just some numbers. Please take note that inside the parenthesis between x and the h, there is a inherent negative sign built into this form or formula. So please take a note of that. So we're going to try to see what the different numbers are represented in different equations. So you have a vertex form of expression. Can you tell what is a and h and k? So looking at this, I'm doing the first one for you. A is the number that is being, okay, so there is a portion that x minus h, x minus something is all being raised. The number in front of whatever is being squared is the a value. H is the number inside the parenthesis followed by the negative sign. And then k is the number that is being added to itself. There is no x term being squared or anything like that. Okay, so in this case, negative 4 corresponds to a, h corresponds to 2, not negative 2, just 2. And k corresponds to 5. So there you go. Okay, look at this example. See if you can tell me what a is, h is, and k is. Okay, I hope you know that if there is no number, then the default number is positive 1. Okay, so I know that this is same as 1 times x minus 3, because remember there is an inherent built-in negative sign to this formula, this form. Okay, so we want to convert this into a negative sign, and the only way we can do that, we can change the positive 3 to a negative is if I subtract a negative 3, because negative becomes positive. So it becomes x minus 3 squared plus 1. Now I can pull apart all the parts. A1 is the number in front of the squared term. Negative 3 is the term being subtracted. And positive 1 is the number being added at the end. What about this? 2x squared minus 10. Well, this is same as 2x plus 0 squared plus negative 10, right? So what you're adding is a negative 10. So again, you can always separate this negative 10 as adding of its opposite or adding its negative. And when you do not have the h value, you can always add or subtract the 0 to any value without changing its value. Okay, so the number you can stick in just to make so that you can see what h value is 0. Because x squared is same as x plus 0 all squared. So from here, I can tell that a is 2. That's the number in front of the parenthesis. The number being subtracted will be 0. So h is 0. And then k is negative 10. What about this? Negative x minus 4 all squared. This is same as, in this case, it's not just negative, but it's negative 1 is being multiplied to x minus 4 all squared. Remember, when there is no number in front, then you can always put negative, or you can always put 1 in front. And we don't have some number being added, so we can just add 0 to it as a placeholder so that we know what k is equal to. So a is the number that is being multiplied in front of the parenthesis that contains the x term, and h is the number that is being subtracted by x, so that's 4, and k is the number that is being added, so k is equal to 0. Working with vertex form. So if you have a quadratic equation written in the vertex form, which attributes can I find out? Well, you can figure out whether it's opening up or down, vertex, line of symmetry, y-intercept, and the x-intercepts, maybe. Okay, so to explore, I want you to go to Desmos graphing calculator. That's by pulling desmos.com/calculator. And I want you to type these equations and figure out the vertex, whether it's opening up or down, and where the x-intercepts are. Okay, so please pause the video and try them yourself. Okay, so when you go to desmos.com/calculator, it's going to give you option for you to write the equation. I've already done that for you. Okay, so in this case, this is the very first equation. It looks like this. All right, what is the coordinate of the vertex? Vertex, I can click on this and it gives me 2, 1. What about the x-intercept? Does it go through the x-intercept, x-axis? No, it does not have any x-intercept because it does not go through. What about the second equation? Okay, let's get rid of this one. The second equation, the vertex is 2, 1 again. And the x-intercepts are 2.577, 0 and 1.423, 0. So if you just click on the x-intercept, it's going to give you the coordinate. Let's try the third graph. That's with negative 0.5 being multiplied. So a in this case is 0.5. And again, the vertex is 2, 1. No x-intercepts. And the last one, the x-intercept, the vertex is the same, 2, 1, and the x-intercepts are 0.586, 0 and 3.414, 0. So here is what you should have discovered, and you should take the notes down if you have not done so already. Okay, notice that the vertex, oh, I did not do this correct equation, did I? Okay, the vertex is always going to be the h value, okay, the number that is being subtracted. So it's going to be negative 5, negative 2, and in this case negative 5, negative 2. Okay, so it's regardless of whether it's going to be positive or negative, the number in front, the vertex is going to be the same. But when it's positive 0.5, it's going to be opening up. When it's negative 0.5, it's going to be opening down. Okay, x-intercept, when it is opening up, with the vertex being below the x-axis, yeah, it's going to have x-intercept, but none if it's opening down. So the key things you should realize is that when the equation is written in the vertex form, y is equal to a multiplied by x minus h all squared plus k. For y is equal to 3, x minus 2 all squared plus 1, the vertex is, look at the number that is being subtracted. If there is no subtraction sign, then you want to change it to subtraction by changing both the subtraction and making this to negative as well. So this in this case is just 2, 1. So the vertex is 2, 1. When you have numbers in front like 3 or 0.5, what does it do? Okay, when you have 3 in front, it stretches vertically, stretches the parabola vertically. It's almost as if you're pulling it apart from top and bottom, and so you're forming a skinny parabola, while as if it's less than 1, it pushes it down, so it becomes a fatter parabola. However, on top of that, A also decides whether it's going to be opening up or down, just like we did it was the case in factored form. So y is equal to 3 and negative 3. So in this case, negative 3 tells me it's going to be opening down. Positive 3 tells me it's going to be opening up. And the vertex is always going to be the same. Okay, so let's try another example to figure out all the attributes. So y is equal to negative x plus 2 all squared plus 7. Now this is the vertex form. And can you figure out what A is represented as, H is, and K is? First thing is, when I have y equals negative x plus 2 all squared plus 7, I can convert this as, I can add negative 1 right there. Okay, instead of no number there, I want there to be some number, and the default number, if there is no number, is 1, because 1 times anything is that anything. So you're not changing the value, so that is a legal move. So negative 1 is my A value. What is H? Okay, so I change the plus into negative, negative. Okay, because two negatives become positive. So again here, I have not changed the value at all inside the parentheses. X minus minus 2 is same as x plus 2. And the reason I did that is because I wanted to get this in the negative subtract form. Okay, subtract by what number? Subtracting negative 2. And K is going to be 7. So is the graph opening up or down? It's going to be opening down. Why? Because the A value is negative 1. So it's negative, so we know that it's going to be opening down. What about the x-intercepts? Well, for now, we're just going to say we do not know. Hopefully, we'll be able to cover this later on. But sometimes you might not even have one. Okay, remember we saw 2 out of the 4 parabolas that we explored. They did not have any, right? What is the y-intercept? That's pretty easy because y-intercept of x-coordinate of the y-intercept is always 0. That means we can go to our original equation and substitute 0 for x. And so you're left with 0 plus 2 all squared, and take a negative of that, plus 7. And that's going to be 2 squared. Take a negative of that. That's going to be negative 4 plus 7, which is 3. So I know that y-intercept is 0, 3. What about the vertex? Vertex is the easy one. You know that it's going to be h, k, and h we said was negative 2, and k we said was 7, so it's negative 2, 7. And we know the equation of the line is always going to go through the x-coordinate of the vertex. So it's going to be x is equal to negative 2. Because line of symmetry is a vertical line that goes through the vertex.